Hello, today we are going to practice solving quadratics, and we're going to start by using completing the square. So we've been dealing with completing the square before in terms of writing it in vertex form, but we just got done doing solving by square rooting, so we're going to try out this method. So in order to complete the square, we would put those together and say we have to take out our a value, which is 5. When you do that, you'll have x squared, and then you have to take the negative 6 and divide it by 5. So that would be negative 6 over 5. X, when you complete the square, you're adding a blank, and then you have the minus 19, and then you're subtracting blank equals 0. So, I don't know about you, but filling in this blank would be a little messy, right? We'd have to take this value divided by 2 and square it. It's definitely doable, but it's messy. So instead of doing this, there is a thing called the quadratic formula. Okay, so this is super useful if completing the square looks messy like this and you can't factor it. So let's derive or come up with how the quadratic formula came to be. Okay, so you start with a quadratic in standard form. So ax squared plus bx plus c equals 0. Okay, starting with the quadratic in standard form, and when you're solving quadratics, just like if you were to factor this, it has to be equal to 0. So I'm going to go through this quickly. I'm not expecting you to ever redo this, but I just want you to see why the quadratic formula is a thing. It's not just something that some random person made up. Okay. So, using a, b, and c, I'm going to complete the square, or solve by completing the square, to show you where the quadratic formula comes from. So in order to do that, when you complete the square in an equation, you can subtract c. That could be your first step. So you'd have ax squared plus bx, and then equals negative c. Okay, from here you want to complete the square with that side, which means you got to factor out the a value. When you do that, you'll have x squared, and you have to divide b by a because you're factoring it out, times x, and plus blank equals, still have your negative c, and what you add to one side, you have to add to the other. I know we haven't done this, but just bear with me. So from here, to figure out what goes in the blank, just like before, we would take this, whatever this value was, and divide it by 2. But like we've been talking about, instead of dividing by a number, you could always multiply by the reciprocal. So if you multiplied by the reciprocal, you can multiply it by 1/2. This would become b over 2a. But this doesn't go in the blank. We have to square it. So what ends up going in the blank is b squared over 2 and a squared, so 4a squared. So when you put that in the blank, what you do to one side, you have to do to the other side. But since there's an a on the outside, you're going to have to multiply these two together. So you have, I'll do it on the side, b squared over 4a squared. You're multiplying that by a, or in other words, a over 1. So what actually goes in this blank, because the a's would cancel, or one of the a's really, you'd be left with b squared over 4a. Now from here, to solve by square rooting, you would now factor x squared plus b over ax plus b squared over 4a squared, which using the shortcut is just taking that value, x plus b over 2a squared equals, then you still have the negative c plus b squared over 4a. Instead of having there be two terms here, let's try to get it to be all one term. So we'll have to add these together. In order to do that, we're going to have to get common denominators, which is 4a. So you're multiplying the top and the bottom by 4a. So I'll show that on the side. When you multiply those together, you'll have negative 4ac plus b squared all over 4a. Most people don't really like to have a negative out in front. They prefer the squared variable first, so we're going to write it as b squared minus 4ac over 4a. Okay, so I'm going to write that down. We got our common denominators. Squared equals b squared minus 4ac all over 4a. Now from here, we have to get the squared stuff by itself, so we need to get this by itself so we can square root. So in order to do that, we need to get rid of this a. We can divide by a, but instead of doing that, I'm going to multiply by the reciprocal, 1 over a. Multiply 1 over a. I'm doing that so these will cancel out, which is great. And then we'll have x plus b over 2a squared equals, and when you multiply this, you have b squared minus 4ac all over 4a squared. And now we have the stuff that's squared all by itself, which is awesome because now we can square root both sides. This is looking like crazy stuff, but this is what somebody did to figure out the quadratic formula. Aren't they smart? So when you take the square root, those cancel. So you have x plus b over 2a. Remember, when you take the square root, it's a positive or negative. And if you recall, one of our properties of square roots is that you can take the square root of the numerator and the square root of the denominator. And if you notice, the square root of the numerator, that doesn't simplify very nicely, so we're going to leave it as b squared minus 4ac. But the square root of the denominator, the square root of 4a squared, well, the denominator just becomes 2 times a. And notice that the other denominator is 2a, so that's so nice, because when we go to move over this b over 2a, it's a plus, so we subtract b over 2a minus b over 2a. X will be all by itself because those cancel. So we are left with x equals, and all of this, negative b, and notice that they have the same denominator, so we can write them together, plus or minus the square root of b squared minus 4ac all over 2a. And would you look at that, x is all by itself. This, my friends, is called the quadratic formula. So this, out of all that mess, this is what I want you to write, the quadratic formula. This is the equation that you are going to be using to solve quadratics. This is the thing that you'll have memorized very soon, I'm sure. There's tons of songs out there, but we are going to use this to solve. And this will work to solve for any quadratic if it's not factorable or if it's kind of intense to use completing the square. So this is our formula. We're going to use it. Make sure you have it written down. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so looking at this first example, it's equal to 0, so that's great. I'm going to list out what a, b, and c are just to help us. A is 3, b is positive 2, and c is negative 21. So what we're going to do is just plug them into our equation, our quadratic formula, to solve for x. So what that means is x equals negative b, or opposite of b, so negative 2 plus or minus the square root, and when you substitute in, put it in parentheses, 2 squared minus 4 times 3 times negative 21 all over 2 times a, which is 3. Now, what's nice about this is if you're using the quadratic formula, you're probably going to be using a calculator. So you can put this entire thing, all of that under the square root, just put that in your calculator. Don't put the square root in, but just put everything that's underneath the square root in your calculator. When you do that, you'll end up getting x equals negative 2 plus or minus the square root of 256 all over 2 times 3, which is 6. Now, if that square root was not, we have to double check to see if the square root is simplifiable. So, can we simplify this thing? And hopefully you're thinking in your mind, well, yeah, 256 is a perfect square, which is awesome. So our next step is negative 2 plus or minus the square root of 256 is 16, all over 6. And just like before with that plus or minus, that gives us two equations. One of them, or two answers. One of them is x equals negative 2 plus 16 all over 6. The other one is x equals negative 2 minus 16 all over 6. So when you simplify the top one, negative 2 plus 16, so positive 14 over 6. But you should be thinking those are both even. I can simplify them, and you should. So your answer will be 7 over, whoops, not 2, 7 over 3 when you divide them both by 2. That is one answer. To get your other answer, negative 2 minus 16 is negative 18 over 6, which simplifies to be negative 3. Since these answers are relatively nice, what that tells us is we could have factored this. We didn't have to use a quadratic formula, but it will work every time. So if we take a look at what we started with, to factor it, you could ask yourself when you set up your factors, have it equal to 0. You know the first blanks will be 3x and x because they have to multiply to be 3x squared. The other two blanks have to multiply to be negative 21. So one's positive, one's negative. And you would guess and check to figure out that it's negative 7 and positive 3. Right? To double check, you have positive 9 minus 7 adds to be your positive 2. So you could have factored this and gotten your same answers, or use the quadratic formula. Either way, but just note that this way will not always work. So speaking of that, let's try one more example. Number 2. So once again, quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And just like last time, I'm going to list out what my a, b, and c are so I don't mess anything up. Oh no, but it's not equal to 0. So in order to get it equal to 0, we're going to have to move that 23. Since it's positive, we're going to subtract 23 from both sides. So that would mean my actual equation in standard form looks like that, which means my c value is negative 23. From here, I'm going to plug them into my equation. Opposite of b, so positive 3 plus or minus the square root of negative 3 squared minus 4 times 9 times negative 23 all over 2 times a, or 2 times 9. When you simplify, remember, just put this stuff that's under the square root in your calculator. You should get 3 plus or minus the square root of 837 all over 18. Now, if you put that in your calculator, you'll be able to see that the square root of 837 is not a perfect square, which what that means for us is we have to simplify square root of 837. When you do that, if you do the factor tree method, you'll see it's divisible by 3, and 3 times 279. Then you break it down even further, 3 times 93, and 93 is 3 times 31. But remember, when we're doing the square root, we're looking for two of the same numbers, which means we have 3 and 31 still left, which means we have x equals 3 plus or minus. 3 comes out, 93 stays in, all over 18. But notice how all of these are divisible by 3, so we can divide them all by 3. So we have 1 plus or minus 1 root 93 all over